was, what's the first order of operations here? What's the first thing I would do? Well, the first thing I would do is take care of what's inside the parentheses, x plus 2. So x plus 2 is my inside function. Once I knew what that value was, it's 3, what would I do with that? I would take the result of this and raise it to the negative 1/2 power. So my outside function is x to the negative 1/2 power. Let's see if that works. If this is true, then I can come down here and I can say, okay, it's f of g of x. That means f of x plus 2. That means that I'm going to use x plus 2 as my input expression into function f. I'm going to take x plus 2, and everywhere I see an x, I'm going to, so that would mean that I'd have to place it here, and that, does that put me back to where I was? Yeah. So that, the one thing then is, if you're a little confused, just ask yourself, okay, if I knew a value for the input, x is 3, what's the first thing I would do? First thing I would do is add plus 2. Why? Because it's inside. It's the parentheses here. Okay, so that's the first thing. Now, we haven't taken the derivative yet, and actually this problem isn't even asking us to, but hey, let's go ahead. Let's try it anyway here. So we're going to take the derivative, and I want the derivative of this. I'm going to write it one more time here. Okay. So we're going to find the derivative of that. So that means I'm looking at dy dx, the derivative of my output with respect to my input. And remember now, the derivative of this, we can do it a couple of ways. One is, if I know what g of x is, can I find the derivative of g prime of x? If I know g of x is x plus 2, the derivative of that is just simply 1. Well, what about the derivative of f of x? It sits there by itself. Let's see, I'll go back up so we can see it. That would be negative 1/2 x to the negative 3/2. Good. Yeah, always subtract 1, remember, so I already have a negative 1/2. Okay. If I'm going to, I don't want to go back and throw the u's at you because I don't want to confuse anyone more than maybe you feel you're confused already, but let's look at it this way. This is going to be the derivative of the outside function times the derivative of the inside function. Now I can see already that I'm going to have to go back and kind of do a little bit of cleanup for you here. Let's see. If I'm going to do it this way, I'm going to have to go back and use the u's. So give me a moment here. I'm going to go back here. We'll just go up here and do it. It might be easier, and you can always go back and look at the videos and see how we did this. If we go up here and we say let's let u equal, and I'm going to say let u equal g of x, x plus 2. That's not too hard, is it? We're just going to let u equal that. Down here then, I can say this is the derivative of u with respect to x, and that's still going to equal 1. That's not changing anything. Okay. If I'm going to let u be x plus 2, then I'm going to have to let y equal u to the 1/2. negative 1/2? Think about it. If u is x plus 2, is that the same thing as u to the negative 1/2? Okay. Well, what does that mean down here? Well, that means then that I've got dy du. Remember, this is y equals u to the negative 1/2. So this would be negative 1/2 u to the negative 3/2. Okay, now the chain rule says this, and we're using the chain rule here, so I'm going to put it up here so we can remember. Chain rule. We've got the outside function, that's negative 1/2 u to the negative 3/2 times the inside function, which is just simply 1 at this point. So let's see, that should just be simply negative 1/2 u to the negative 3/2 if I multiply by 1. But I got a problem. This is supposed to be dy dx. Do you see the problem I've got? What's the input variable? What's over here? Can't do that, okay? Can't do that. I'm going to have to go back now and in place of u put in what it represented, yeah, in order to be true to my notation. My notation says the input variable is x. It has to be there. I can't let it sit there as a u because that's not being true to my notation. So my derivative then is this. Now that's the first way of looking at it. That's going back and using, you know, dy dx is equal to dy du times du dx. Remember, when we do this chain rule, those differential du's cancel out, and we're back to, this is what we did. We have the dy du, that's this, and the du dx is here, and we, you know, basically, we didn't actually go through and cancel those, but they cancel by nature of what they are. But let's look at it now with the alternate, and the alternate is this. Let's go back and look at this. Are we doing anything different? This represents the inside function. What does this represent? Inside function also, right? What does this represent? Derivative of the outside. What does this represent? Derivative of the outside. It's the same thing. Okay, but the notation looks a little different, but it's always going to be the same thing. But here's what it's going to look like in our work. So I'll put another line down here. Let's see, this is y equals x plus 2 to the negative 1/2 power. We're going to have to decide which one is easier to work with. Sometimes it's going to be easier to use that dy, du, dx, you know, the chain rule. Other times it's going to be easier to use this method. I want the derivative of y with respect to x. I'm going to rewrite this. It looks almost like it's times 1/2, and that's not the case. So just make sure it looks like an exponent. I always ask myself the question, what's the outside function and what's the inside function? We've already discussed that. We know that the inside is x plus 2. The outside is to the 1/2. Now, bear with me on this. You can put anything you want. But if I had just something as silly as smiley faces in there, and I said I have something to the negative 1/2 power, you tell me the derivative is negative 1/2 times those silly square, you know, negative 1/2 times those things to the negative 3/2, right? Doesn't make any difference what you have in here. The outside function is taking a quantity or an expression to the negative 1/2 power. And I'd end up with this. Now, we're not going to keep the smiley faces. They're kind of cute, I think, but we're not going to keep them. Instead, we're going to go back and remind ourselves what it is we actually have behind those smiley faces, and that is x plus 2. Then we take the derivative with respect to x of, which part? This is of the outside function. This is now of the inside function. Okay? So we're doing the same thing. We're taking the derivative of the outside function, and if you need to, cover it up literally or figuratively. Cover it up and say, what am I doing? I'm taking something to the negative 1/2 power. That's the last thing I'm going to do in this function. First thing I'm going to do is add 2, and then the last thing I'm going to do is take that answer to the negative 1/2. So my outside is raising to the negative 1/2. I take care of that outside function derivative first, then I take the derivative of the inside. Do I get the same thing? Yeah, I get the same thing. Okay, now this is what we call the chain rule, and we just need to kind of work our way through it, and I'm not necessarily going directly as the book has it, so if you read the book, that's just going to reinforce and bring more understanding to you if you're needing that. But let's take a look at this. I'm given y equals 2 the square root of u, and I'm given u equals 5x plus 9. Can you build a composite function from those? Would you know which one is the inside and the outside just from looking at this? Which one is it here? Which one's inside? Pardon? If I'm given this information, you know, these two quantities, I'll highlight them here. This is one, okay, and then this is the other. If I'm given that information, can you see a composite function? Nick, what do you see there? Yeah, because
the u is the input.
yeah, here I only have the value u, and so if I have an expression, so we could say this is 2 times the square root of 5x plus 9. That would be my composite function, because I can replace this u with the expression 5x plus 9. Now, this problem's not asking us to do this. This is where I'm taking off my own little tangent, puns intended here, my own little road side trip here, but we can do this. dy du, which of these am I going to use? Well, better use the one that has an input of u and an output of y. So I'm going to, if I'm going to use dy du, okay, so dy du is going to come from this one. I'd be better off, I think, if I started with, let's move this stuff down here. I'd be better off if I started with maybe rewriting that function first. Maybe doing something like y equals 2 times u to the 1/2 power. Because now if I want dy du, I would have 2 times what's the derivative here? 1/2 u to the negative 1/2. Okay? So this one is coming from there. If I'm going to do du dx, which function am I going to use? I'll look for the one that has the input of x and the output of u. So that's going to come from this one. And so du dx is simply 5. Okay. Oh, thank you.